In this lesson, I'm going to show you how to graph a system of linear functions to find the solution. So first of all, let's talk about what a system is. A system is simply two or more functions working together to find the solution. The solution is going to be the point of intersections of those two lines. So remember, a point is an ordered pair which has an x and a y value. So for each system, we will be finding two values, the x and the y. Now remember that the solution is the value, or in this case, values that when you plug into the equation, it makes it true. And for us, we're going to be looking at two equations. So we're going to plug in those values, the ordered pair, into both equations, and it will make both equations true. Now, there are three methods to solve systems. There are three methods to find that point of intersection: graphing, and two algebraic methods when you don't have a graph: substitution and elimination. For this lesson, we're going to focus on graphing only. So, pause the video and take down these notes. These are the three types of solutions for your system. You can see, starting on the left, that these two lines, the blue and the green line, intersect at one point. So this solution is -1, 1. This system has one solution. In order for a system to have one solution, they must have different slopes. So if you don't have the graph, but you have your two equations and they have different slopes, you know that they are going to cross at one point. Then we have a solution set that's infinite solutions. And even though you can't see the green line, it lies along the blue line. And this gives you infinite solutions. Every ordered pair makes both equations true because ultimately they are the same line. We say that these lines coincide, so make sure you write that word down. When things coincide, they lie along the same location. The last type of solution is no solution. You can see the blue line and the green line start at different y-intercepts, but they have the same rate of change, up 1 over 1, up 1 over 1. So they will never intersect. These are called parallel lines. So make sure you know that a system that has no solution are parallel lines, and parallel lines have different y-intercepts, but the same slope. So they start at different places, but they change at the same rate, and they will never intersect. So here are the three types of solutions. One solution where they cross at one point, infinite solutions where they cross at every point, and no solution where they cross at no points. For this part, we're going to skip. This is where you could use the Desmos graphing calculator and insert both equations and see where it crosses on the graph. So instead, we're going to get straight to graphing by hand. But before we do that, let's take a look at a special system where they cross at one point. So here would be our ordered pair, and this would be 3, -2. But look to see when they cross, they create right angles. These are called perpendicular lines. And you need to be familiar with what a system looks like that has perpendicular lines. Let's look at the slope. The slope for the green line is -3 over 2, and the slope of the blue line is 2 over 3. So when you have slopes that are opposite in sign, one is negative and one is positive, and they are reciprocals of each other, you create perpendicular lines. So please take note that all perpendicular lines have opposite reciprocal slopes. Make sure you write that in your notes. Now, graphing systems is very easy since we already know how to graph a linear function. The main point that you need to write in your notes is this, that your equations must be written in slope-intercept form, where your y is isolated. Y equals mx plus b. So let's get started. Here we have two equations, and we are going to graph those to see where they cross on the coordinate plane. However, we need to have them in slope-intercept form. So that's always step one. So we are going to isolate the y and subtract the linear term. We're going to bring down negative 2y. I like to put my slope term first. And then we're going to divide each side by the negative 2. So this equation in slope-intercept form is positive 7 over 2, because a negative divided by a negative is positive, and minus 4. So let's go ahead and graph this one. We're going to start at negative 4. We're going to go up 7, 1, 2, 3, 4, 5, 6, 7, and to the right 2, 1, 2. We can try one more, 1, 2, 3, 4, 5, 6, 7, and to the right 1, 2. So I'm going to try to make a nice straight line. It's not very straight. And for this, we are going to graph as many points as we can. Now let's isolate the y in our second equation. We're going to subtract x from both sides. Bring down positive 2y equals, I have a negative 1x plus 8. Divide by the coefficient 2. We have y equals, this is an understood negative 1 over 2 times x plus 4. So this time we're going to start at positive 4 and go down 1 and right 2. Down 1 and right 2. So here is our second equation, and you can see where they cross. This is the solution, the ordered pair, that makes both equations true. If I plug in 2 for x and 3 for y in both equations, I would get true statements. Let's try example number 2. Y equals negative 3x plus 2. We can go ahead and graph this. We're going to start at positive 2. Our slope is down 3, and to the right 1, down 3, and to the right 1. So we'll see if this is enough points. If not, we can graph more. Our second equation, we need to solve for y. We bring down negative 1y equals negative 4x plus 5. Divide by your understood negative 1. And we have y equals positive 4x minus 5. We're going to start at negative 5. We're going to go up 4. 1, 2, 3, 4, and to the right 1. And we can see that we cross right at that point. So as soon as you see the intersecting point, you can stop graphing. So this solution is 1, negative 1, the point that makes both equations true. Let's look at example 3. Again, we need to put them in slope-intercept form before we graph. And also, if you were to use Desmos calculator, you would need to make sure they're in slope-intercept form. I'm going to graph these, but go ahead and notice they have the same slope of negative 1 and different starting points. So the first one, we're going to start at negative 1, and then we're going to go down 1, right 1, down 1, right 1. So we can see this line. And then the second one, we're going to start at negative 2, and we're going down 1, right 1, down 1, right 1. We can see that these two lines will never cross, and they are parallel because they have the same slope. So same slope, and different y-intercepts give us no solutions because these are parallel lines. There is no ordered pair that will make both equations true. Okay, let's graph this one that's in slope-intercept already. We start at -1. We're going to go up 5. 1, 2, 3, 4, 5, and over 1. We'll see if this is enough points. And now let's solve for y in our second equation. Divide everything by -3. A negative divided by a negative is positive, so we do have a positive slope. We're going to start at -1. So look, you can see they both have the same y-intercept, so that's going to be our solution. But let's go ahead and graph this line. 1, 2, 3, 4, 5. To the right, 1, 2, 3. So you can see, whoops, not very pretty, but you get the point. Get it? The point. So the slope-intercept, 0, -1, they both had the same y-intercept. They both started at the same point, but they had different slopes. So when they have different slopes, you're going to have one solution. So remember, different slope equals one solution. And their solution was the y-intercept. Okay, let's go ahead and graph one more. Y equals -4x minus 6. They're both in slope-intercept form. I'm going to start at -6. I'm going to go down 4, 1, 2, 3, 4, to the right 1. I'm going to go ahead and graph a few more, and I am going to, instead of going down and right, I'm going to go up and left. 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. 1, 2, 3, 4. Sometimes you need to use your slope in the opposite direction, but it still indicates a negative slope here. Now we're going to start at +7, and we're going to go up 1 and right 3. 1, 2, 3. I can see that this continuing this way, I'm not going to intersect the other line. So I'm going to, again, reverse. I'm going to go down 1 and to the left 1, 2, 3. And I can see that those lines cross at -3, 6. So make sure you know how to use slope in reverse. And I hope this helps.